Hi, my name's Stuart Lynch, and this is the second of 9 videos in the Building a Wordle App clone series. In this video, we'll begin our UI design by creating our game board. We'll be creating our model for each guess and a data model class to handle all interactions for our view. We'll also be creating an extension to the color view along with a global constants file to make our code readable and easier to deal with. If you like this series, please leave a comment below and give the video a thumbs up. Be sure to subscribe to my channel and make sure you ring the bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. For every new video, I like to create a new Git branch so that if necessary, I can always go back to an earlier video and either change the code or go over a particular topic once more, so I encourage you to do the same. You can do this by selecting the Source Control Navigator and the Repositories branch. Then expand the branches where you'll see your single main branch. Right-click on it and choose New Branch from Main and call it Lesson 2. Make sure as well that Lesson 2 is checked out as the current branch. The first thing I'm going to do is rename our content view to GameView, because that's what this view is really going to represent. Make sure as well that you rename the comment in the header and the preview struct. In fact, there will only be 4 view screens in this app. One for the game, one for the help screen, one for the game settings, and one for the statistics. 2 will be presented as modal sheets, while the statistics view will be overlaid on top of this view. However, in all cases, we'll want a button to be able to access them by toggling some Boolean property. And we're going to do this by embedding our game view then in a navigation view and adding 3 buttons and a title. So first we'll embed the text view in a navigation view. Now I don't want a large title bar, so let's set the navigation bar title display mode to inline. I'm going to want more control of my title, as when we are in hard mode, I'll want to set the color to red, but I'll get to that later. In the meantime, instead of creating a navigation bar title, I'm going to use a toolbar and add 3 toolbar items, one of which will be the title in the principal location. But first, let's create a toolbar, and then inside there, a toolbar item with a placement of navigation bar leading. I'm going to create a button in there, and I'll leave the action empty, but I'll change the label to be a system image using the $.circle. This is what we'll use to present our help screen. I'll create another toolbar item, but this time I'm going to set the placement to principal. That's the center of our navigation bar. And then the item content, I'll set it as a text view using the string Wordle, all in caps. I'll change the font to large title and set font weight to heavy. And for now, I'm going to set the foreground color to primary. As I said, we'll return to this later when we implement hard mode. For the final toolbar items placement, it will be navigation bar trailing. But this time, we'll need to create 2 buttons. So we'll need an H stack with 2 buttons inside. We'll leave the actions empty, but for the label, we'll make them both images with system names. We'll use chart.bar for the first and gearshape.fill for the second. Notice how the buttons have taken on the color of our gray accent color? We're going to be working a lot with the colors that we've added to our assets folder. So I want to create an extension for the color type so that I can, when I want to, have easy access to those colors. So we'll create a new group called Extensions. Inside there, I'll create a new file that I'm going to call color plus extension. And I'll change the import to SwiftUI and create an extension for color. Within the extension, I want to create 5 static properties. And for the first one, it's going to be wrong, that is of type color. And then we can use the color using UI color named wrong, making sure that we spell it correctly, and we'll need to force unwrap it. Now I can just copy and repeat this 3 more times and replace wrong with misplaced, correct for the second one, and unused for the third. Now, I don't know why there isn't a standard SwiftUI color property for system background, like there is for UI color, but we can create our own. Great. Now we can work with these colors to build out our UI. Now we can start designing our game board. It's going to be a set of 6 rows and 5 columns of text views, where the text views are squares, where the background and foreground colors will change depending on the state of the guessed letter. Each row corresponds to one of the 6 guesses or attempts, and each column is a letter of the 5-letter word that's guessed. Therefore, for each guess, I need to know the guess attempt or the index. I'll need a word consisting of 5 letters that we can break out into an array of strings, along with an array of background colors that will change. These colors will be updated when we evaluate the guess. And those background colors will also be updated one after another and not all at once. So I'll need to keep track of the flip status of each row. For that then, I'll need another array of 5 Boolean properties. So let's create a model for that with some default values that will reflect the state of the guess before any letters are entered. So we'll create a new group called models. Inside that group, I'll create a new file that I'm going to call guess. And inside there, I'll create a struct of the same name. Now we'll be needing an array of color, so I'll have to change the import to SwiftUI. So we need to create those properties. First, index is an int, and it's a let because it's created when we create the object and never changes. Word will be a string of 5 characters that are initially just 5 spaces. The background colors will be the same as the system background initially. So we can create an array of color using the repeating initializer with system background and a count of 5. And the cards flipped array will be all initially false. So again, another repeating array of Booleans for a count of 5. I mentioned that we want to break out that word into an array so that we can actually iterate through each of the letters for comparison purposes. And we can do that with a computed property that's an array of string. And this could be found by mapping each character of the word, converting it to a string. The guess view then is a perfect case for an HStack that contains 5 of our guess objects. Now we're going to want this to scale for our different size devices. For the iPhone, we want it to extend pretty much to the width of the screen, but for the iPad, we want to limit it to a maximum width so that we'll be able to fit the keyboard underneath, whether in landscape or portrait mode. We'll also want 6 of these in a VStack, so we'll be confining that VStack to those dimensions that will be a ratio of 5 by 6, resulting in our guess to be a perfect square. So as far as us designing the views, we're going to allow each of our guesses to expand infinitely high and wide, and then confine them when we enclose them in a frame in our GameView, letting SwiftUI set the frames based on the available space. So let's start by defining the opening or front view then. Create a new group and call it Views. And we'll move the game view inside that. Next, create a new SwiftUI view and call it GuessView. And this view is going to need an instance of our guest that will be updated as we make our guesses. So we'll make it a binding. For the preview, you can just use a constant of a guess object, and the only thing you'll need to pass in is the index. So let's just pick 0. We'll replace the text view with an H stack and a spacing of 3. And inside the H stack, we'll use a for each loop from 0 through 4, with the ID being self. And that provides us with an index that will represent the corresponding index for the guess word array. Now we can create a text view using that guess's guess letter at the specific index. Now the front of the tile will have a foreground color of primary. There'll be a frame where the minimum width and height are 0, but the maximum width and height will be expanded to infinity. And I'll also set the alignment to center. The background of each one of these blocks is going to be the system background color initially. The font will be a system size of 35 with a heavy weight. And then I'll finish by applying a border of a color of secondary label. That's it for our single row of guess strings. Let me fix this group up first. It's not within this group, but it should be on its own level. I'm going to keep things pretty simple because, believe it or not, there isn't a lot of coding to be done in this app. I'm going to create a single data model that I can inject into the environment where I can pass along all of our words and guesses and any calculations that I want to do on them. So I'm going to call it a data model, and it will act as our view model as well. So we'll create a group called view models. And inside, we'll create a new Swift file that I'm going to call Wordle DataModel. And inside there, I'll create a class called Wordle DataModel, and it will have to conform to the observable object protocol. I'll also change the import to SwiftUI. First, I'm going to have a published property that's an empty array of guesses. Now, each time we start a new game, we're going to have to refresh that array with our default values, along with some other values that will need to be reset every time we get a new game. So I'm going to create a new function called populateDefaults. Inside there, we'll set our guesses back to an empty array because they would have been filled through previous games, and then run through a loop from 0 through 5, appending a new guess using the loop's index. Next, I'll create another function called newGame, and within that function, I'm going to call the populateDefaults function. We'll be doing more things, but I'm looking ahead here. And then finally for this class, when it gets initialized, we'll want to start a new game right away. So when we launch the app, we'll get a new game if one isn't already in play. So we'll create an initializer that calls the newGame function. Well, now that we have our data model, we can inject it into the environment. So at the app's entry point, which is our Wordle App file, we'll create a state object, and I'll call it DM for data model, and initialize it with a new instance of the data model. And then when we present our game view, I'll inject it into the environment. Next, we want to know the width of our screen so that we can adjust the width and height of the VStack that we're going to be putting our 6 rows of guesses in. Now, I did a lot of experimenting with this, so I'm going to save you some grief. Let me share with you this reference that I found where it displays all of the dimensions of all of the devices, all of the known devices in the iOS universe. And then I'll be able to define a range of values based on the width and adjust accordingly within ranges. To make it easier for me to deal with then, I'm going to create a file that holds these calculated constant values. Within the models folder, I'll create a new file and I'm going to call it global. Inside there, I'll create an enum of the same name, and now we can use that as our namespace. So inside here, I'll create a new series of static properties, and that'll require my accessing the UI string object, so I'm going to change the import to import UIKit. I'm going to need three things: the screen width and height, along with the minimum value to tell us whether or not our iPad is in landscape or portrait mode. So first we'll need a screen width, that's a CG float, and that's simply the uiscreen.main.bounds.size.width. The screen height is another CG float, and this is the uiscreen.main.bounds.size.height. So for the minimum dimension then, another CG float, we can just get the minimum of those two properties. So after some investigation, as I said, I've been able to determine that the best scale can be broken down based on a range of the minimum dimensions. So I'm going to create another static property called board width as a CG float, and I'll switch on the minimum dimension, and I'll set up 4 cases. I've broken it down into 4 different cases. First, from 0 to 320, which is up to and including the iPod Touch. Then our iPhones are between 321 and 430 in screen width. And for the iPads, I've got 2 different categories. The smaller ones from 431 through 1000. And then the default will be everything larger than that. For the iPod Touch then, I'll return a screen width minus 55. For the iPhones, a screen width minus 50. And then for our iPads, the smaller ones, I'll max out at 350. And for the largest iPads, I'll max out at 500. Returning now to GameView, we can grab our data model from the environment with an environment object, var dm, which is a Wordle DataModel. And I'll have to fix the preview by injecting it in there too. Now I can replace our text view with a VStack with spacing of 3 and create 6 guess views passing in as the guess the 6 different guesses from our data model array of guesses. And now we can fit that all within a frame that is of a dimension of 5 by 6, using the ratio from our board width. So our frame will have a width of our global board width, but the height is going to be 6 times that global board width divided by 5. And thus, no matter what device we're on, this board will be fit within a 5 by 6 rectangle. And each one of our little letters is going to be a perfect square. If we test this in the preview then, we can see that our board will adjust to the size of our device preview, regardless of the size of that device. We see here for the first device, which is the iPod Touch, it scales nicely. Let's try a larger device like an iPad Air. I see that I have a bit of a problem here. This iPad is trying to create a split view, so we'll have to go back to our content view and specify that the navigation view style is stack to prevent this split view from occurring. Yes, that's better. Let's rotate the iPad. Perfect. Well, in the next video then, we'll be able to push this up and fit a keyboard below in either landscape or portrait mode, and do the same thing with our iPhones. But before we finish this video, make sure that you commit your files to your Git repository. The next video then will complete the UI for our GameView by creating our keyboard.